Today I talk on important topics related to unique factorization theorem for polynomials. We know about that polynomial plays important role in algebra, and obviously we discuss so many polynomials, so many types of polynomials and definition of polynomials and so many related theorem, proposition, lemmas related to polynomial in previous classes. So today we discuss one important theorem related to that polynomial. This theorem is obviously known theorem for all. We know about this theorem. This one is unique factorization theorem for polynomial. Okay, unique factorization theorem for polynomial. Okay. Unique factorization theorem for polynomial. Okay, we now start this one. So we write this statement of this theorem first and then going to discussion of that. Okay, so we write it here for any polynomial fx of positive degree, for any polynomial, okay, fx of positive degree. Then positive degree means obviously this one is, that means degree 1, degree 2 in this way, okay, not constant. So we're going to further discussion of that. There exists, okay, if this one happen, then there exists a unique constant c, a unique constant, okay, c. What happened next? An unique distinct irreducible polynomial, unique distinct, okay, irreducible polynomial, sorry, irreducible monic polynomial. We also know about that monic polynomial is then highest term degree is 1. So highest term of this polynomial is, the coefficient is 1, okay, the leading coefficient is 1. So we're going to that for any polynomial fx of positive degree, there exists a unique constant c, unique distinct irreducible monic polynomial, okay. Monic polynomials phi 1x, phi 2x, dot dot dot, okay, here phi kx, and unique positive integer and unique positive integers, okay, here n1 n2 dot 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 nk. Understand, such that what, such that fx equal to phi c phi 1x whole to the power n1, phi 2x whole to the power n2, dot 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 phi nx whole to the power nk. Okay, sorry, phi kx. Wait, write some mistake here, so we'll add it easily. So what is here, for any polynomial fx of positive degree, there exists a unique constant c, unique distinct irreducible monic polynomials phi 1, phi 2, phi kx, and unique positive integers n1, n2, nk, such that fx is written as then is some multiplication of the power of this irreducible monic polynomials. Okay, so we also write it this statement now. Now we're going to further discussion of, that means proof of that. Okay, we write it proof now. So what we, that means, discuss today, unique factorization theorem for polynomial. Okay, so we're going to prove, we start proof now. We begin, okay, we begin by showing the existence of such a factorization using mathematical induction on the degree of x. That means we also start by showing the existence of uniqueness, by showing the existence of such polynomials. Okay, existence of such polynomial. Okay, also exist, then show this one, existence of such polynomial. Obviously existence of such polynomial factorization. Okay, factorization, then this factorization, and then what happened? Then using what? Using mathematical induction, one important tool in mathematics domain. Okay, that means we prove so many critical theorem or critical, that means problems, by this tool, mathematical induction. Okay, or also obviously this one is familiar to all, known to all, but this one is crucial and important in mathematics domain. Okay, because this helps to prove some theorems, we also utilized in some problems. So this one is plays very important role in mathematics. So we're going to discussion about that. We begin by showing the existence of such polynomial factorization using mathematical induction. Okay, using mathematical induction on what topics? On the degree of fx. Okay, so we use this mathematical induction on the degree of fx. Okay, I understand. I think not a problem at all. So we start it now. Okay, now we also erase that portion and going to further discussion of that. All are understand this theorem, unique factorization theorem for polynomial. All are known about that, but we also discuss in a suitable way. Okay, so I think you understand more betterly. Okay, now we're going to prove of that. What we write, if fx be of degree 1, then what happens? Okay, if x be of degree 1, then we also know about that. Then fx is what format? Fx is ax plus b, or ab belongs to any r. Okay, any constant, and in this way we write it in degree 1 polynomial. This one is too easy. So for next step, what we done, that means we also take set phi x equal to what? A common, then x plus b by a. This one is too easy. If we write here a not equal to 0, we know about that degree of polynomial 1, that means a not equal to 0. Otherwise this one can't be possible of degree 1 polynomial. If a equal to 0, then this one constant, then this one is degree 0 polynomial. Okay, so this one a not equal to 0 here written, then this one is better, so we common a, then x plus b by a. Okay, not a problem at all. Then we write it in this way. We have what we write here phi x equal to phi x, sorry, fx equal to, okay, fx equal to a phi x, fx equal to what, a phi x. That means if fx be a polynomial of degree 1, okay, then what happened, then we also write it in this way. That means some monic polynomial, some monic polynomial multiplied by some constant, and obviously we get this fx. Okay, so we write it in, since phi x is, a an irreducible monic polynomial. Irreducible means, that means not reducible, that means not factored. Okay, that means this one is, they have no factor. Okay, since phi is an sorry, no factor is can't possible, factor is always possible, but otherwise itself and the basically identity, these two are factor of this polynomial. I understand, otherwise we can't handle anyone. That means this one is not factored by that means other polynomial. Okay, without itself, and obviously identity for polynomial is one, we know about that. So this two, or some that means constant polynomial, so these two are not related here. Okay, so we also that means extend this one. Phi x is an irreducible monic polynomial. Okay, irreducible monic polynomial. So what happened, so phi x is irreducible monic polynomial, then the polynomial with positive degree, then what happened, then obviously the then result, okay, is done in this way. That means fx is written as, that means written as what, written as some multiplication of constant with unique irreducible monic polynomial. Okay, and now going further step. Okay, that means suppose that in mathematical induction this one happened, that means we prove this trivial case, then we suppose something. Okay, that means we suppose that the conclusion is true. Okay, the conclusion is true for what, for any polynomial with positive degree less than n, for any polynomial of positive degree, okay, less than n. Okay, obviously n is greater than 1, because we prove this one for 1, n equal to 1. And then what happened, then we also talk about that, that means fx, and again let fx be of degree n, be of degree n. Okay, now we erase that portion and going to further discussion of that. Okay, I think all are understand that portion. Okay, now we're going to further discussion of that. Okay, so what happened here, we write it in this way: fx, if fx be of degree n, then fx equal to what? Fx equal to, in this way, an x to the power n plus an minus 1 x to the power n minus 1 plus dot 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 a1x plus a0. Okay, where an not equal to 0. Understood? I think all I understood that. Or otherwise ai's are some constant or integral number. Okay, or some third k. So we erase that portion and going to be discussion of that. We talk about ai are real number. You also consider that ai belongs to some field k. Okay, there is some constant. So this one have not a problem at all. And now we're going to discussion about that. Okay, so by mathematical induction step we also done for degree 1, and we let degree less than n. This one is true conclusion, and going to further discussion fx b of degree and then what happened. Okay, we erase that portion and going to further discussion of that. I think all are understand this, that means this steps, okay, of this proof of this theorem. So now we're going to further discussion of that. What if fx be irreducible? Okay, if fx be irreducible, then what happen? Fx be of degree n and fx be irreducible, then we write written by fx equal to an common x to the power n. Okay, here we write an minus 1 divided by an, here x to the power n minus 1, and in this way we write a1 by an, here x to the power what? X, and then what happened? A0 by an. Okay, then what this one is, that means then fx written as in this way is a representation, okay, is a representation, sorry, representation, okay, of fx, okay, as a product of an, as a product of an, some constant an and some polynomial. Okay, as a product of an and some irreducible polynomial. Okay, that means irreducible monic polynomial. Okay, understood? Any problem? I think not a problem at all. Okay, next we're going to further discussion of that. That means if f is irreducible, then not a problem at all. Too easily we done it. If fx be reducible, then what happened? Okay, then what happened? Obviously irreducible, we write it in this way, that means in bracket not irreducible, then what happened? Okay, then what happened? Then we write fx equal to, we write it gx multiplied by hx. Okay, where for some polynomial gx and hx, for some polynomial, okay, gx and hx, this one is half value. Understood? I think all are understood that. And obviously each of positive degree less than n, each of positive degree less than n, Why this one is happened? Because we known about first time if irreducible, then some constant with and obviously multiplied by an irreducible monic polynomial with degree n. But here if reducible, then gx and hx obviously multiplied by to these two polynomials equal to fx. And obviously these two polynomials gx and hx contain positive degree less than n. Understood? I think all are understood that. Then we're going to further discussion. The induction hypothesis generates that what? That means both gx and hx, both gx and hx factor as products of a constant and powers of distinct irreducible monic polynomial. Okay, why? Because gx and hx obviously degree less than n means this satisfies the that means given or that means given condition. Okay, that means we let this one happen for degree less than n. Okay, so then supposing condition or assuming condition are satisfied by gx and hx, we write it now. Okay, so what happened? That means the induction hypothesis. Okay, the induction hypothesis generates that. Okay, generates that what? Generates that both gx and hx, both gx and hx, okay, factor as a product of product of what? Product of a constant and product of a constant and powers of distinct irreducible monic polynomial. Powers of what? Powers of distinct irreducible monic polynomial. But it is the above portion now and going to further discussion of that. Okay, then what happened here? Obviously that means the gx and hx as a product of constant and powers of what? Powers of distinct irreducible monic polynomials. Power of distinct irreducible monic polynomial. Okay, understood? Then what happened? Then we write it consequently what? Fx equal to gx multiplied by hx. Understood? Also factors in this way. Then obviously fx equal to gx also factors in this way. Okay, now thus in other case it is lower portion and going to further discussion of that. Okay, now what happened? That means we write it here fx as a thus in either case. Okay, fx can be factored as a product of constant and power of distinct irreducible monic polynomial. Okay, fx can be factored as a okay as a product of a constant and what happened, and power of distinct irreducible polynomial, and power of distinct irreducible polynomial. Okay, irreducible polynomial. Now we're going to prove the uniqueness of this, that means uniqueness of this factorization. Okay, so we're going to next step. We write it now, uniqueness, okay, of this factorization. We erase that portion and write it in this way, uniqueness of the factorization. We also discuss too easily this one. Okay, I think all are understand this theorem. Now we're going to prove the uniqueness of this factorization. What happened? We write it now. Suppose that what? Suppose that fx equal to c phi 1x n1, okay, dot 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 phi 2x n2 to the power, sorry, phi 1x to the power n1, phi 2x to the power n2, and phi nx, sorry, phi kx to the power nk. Okay, understood? Now also we write in this way, d multiplied by psi 1x whole to the power m1, okay, psi 2x whole to the power m2, and dot 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 psi kx whole to the power mk. Okay, sorry, this one is not same, psi rx equal to mr. Okay, we take distinct. Okay, so what happened? CD constant, we know about that, CD constant, and obviously phi ix and psi ix are irreducible polynomial. Phi ix, psi ix are irreducible monic polynomials. Okay, are irreducible monic polynomial. Okay, monic polynomial. And next, what? That means ni and mj are positive integer. Okay, ni and mj are positive integer. Okay, and where obviously I equal to 1 2 dot 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 k, 1 2 dot 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 k, and j equal to 1 2 dot 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 r. Okay, this one phi I and psi j. Okay, so what happened? We also discussed too easily uniqueness of this theorem. Okay, I think all are understand that portion. Now we erase that portion and go into further discussion of that. So we also discuss uniqueness of this theorem. Okay, that means uniqueness part of this proof. So we write it now. What happened? Now clearly both C and D must be the leading coefficient. Both C and D must be the leading coefficient. Okay, the leading coefficient of fx. Then what happened? Then these two are same, hence c equal to d. Next we're going to be proof of that. That means dividing c, and we find that it becomes what? That means dividing c in above, then we get what? Obviously we get in this way phi 1x to the power n1, phi 2x to the power n2, dot 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 phi kx to the power nk equal to what? Equal to psi 1x to the power n1, psi 2x to the power n2, sorry, m1 here, we write it wrong, m1 we construct, m2 dot 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 psi rx whole to the power mr. Okay, then what happened? Then obviously we, that means write it in this way. This one are happen. Okay, we marked it, this one is star, and going to further discussion of that. That means since phi I x divisible, since phi I x, okay, since phi I x divide the right side, divides the right side of star. Okay, then what happened? Then star for this I equal to 1 2 dot 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 k. Okay, then what happened? That means we also write it that each phi I x equal to some psi j x, each phi I x equal to some psi j x. Okay, then and obviously similarly each psi j x equal to some phi I x. Okay, then what happened? Then obviously we write it in this way. That means we conclude that, conclude that what? R equal to k. Okay, so we conclude that what? R equal to k. Not a problem at all. Okay, and by remembering, if necessary, that means phi I equal to psi I x, if necessary. Okay, if necessary phi I x equal to psi I x, then what happened? Phi I x equal to psi I x. Okay, then what happened? For I equal to 1 2 dot 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 k, and suppose that ni not equal to mi for some I. Okay, that means this one is happen, and let now, or suppose that ni not equal to mi, then what happened? That means power is different. Okay, if power is different, then what happened? Then without loss of generality, we may suppose I equal to 1. We erase our portion and write it now. That means this one is done, I equal to k. Now we're going to discussion of that. That means to the power are different, then what happened? Okay, so that means suppose for I equal to 1, n1 greater than m1, then what happened? Okay, then obviously by cancel cancelling phi 1x, okay, to the power m1, then what happened? Okay, from both sides of star, we get what? We get this one, phi 1x whole to the power n1 difference m1, okay, and remaining are this one, phi 2x whole to the power n2 dot dot dot, okay, here phi k x whole to the power nk, and here in this way psi 2x, psi 1x is not here, psi 2x whole to the power here m2 dot 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 psi kx whole to the power mk, because we also proved that r equal to k, okay. So this one is done. Next we write it, this one mark is double star, okay, and going to further discussion of that. Then what is here, we write it in this way, since n1 difference m1 greater than 0, okay, then what happened? That means phi 1x, okay, phi 1x divides the left side of double star, phi 1x divides the left side, okay, left side of this double star, okay, equation double star. Then what happened? Then again we write it phi 1x equal to, and that means then phi 1x equal to again some psi means some phi, that means phi kx, okay, or another one, that means phi ix, okay, anyone have that phi ix for some I equal to 2 dot 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 k. Why? Because phi 1x equal to psi 2 to psi k in this way, anyone, and so we'll let, that means any phi 1, okay, that means psi I equal to phi I, so this one happened. Then obviously we also, that means done that this one is some contradiction, because phi 1 is contradiction happen, because phi 1 is irreducible monic polynomial and all are distinct irreducible monic polynomial, so this one is not possible, okay, since phi i's are distinct irreducible monic polynomial, okay, irreducible monic polynomial, so this one is not possible. Understood? So we arrive a contradiction. Then what happened? Then obviously ni equal to mi. Understood? Ni equal to mi happen. So that means what we get? We get the unique factorization of fx. Then we get the unique factorization of fx, okay, unique factorization of fx. I think all are understood that theorem, okay. Too easily we discuss that, and obviously too elaborately we discuss. If you get this type of video, please subscribe my channel. If you give like, please click on like option. If you have any questions, suggestions, comments, write it in comment box. So please subscribe my channel. Now today we stop here. Thank you.